Okay, well, today we're going to talk about optimization for performance, efficiency, and sustainability. For resin embedded, we used to also call it chemically fixed. We discussed it a little bit lately, and resin embedded is maybe a little bit more accurate to include things like high pressure freezing and freeze substitution. Um, Specimen prep procedures need to be effective, consistent, and robust. Our protocols and workflows are often unoptimized because we've always done it this way, and changing things is difficult. Revalidating is not popular if you don't have to do it. So there are some reasons to keep things status quo in many cases. Today, we'll discuss trends, tools, strategies to analyze and update your workflow. This is intended to be an interactive forum. A lot of the things I'm going to discuss have different people have different opinions, and some of them may be okay to go either way, some of them may not. So I would like to have your input as we go through here. So please contribute. And I'm going to minimize something here. There we go. Um, so what are the challenges that we all run into? We have inherited versus empirically derived protocols. And I picked this up from this paper um, in Nature Protocols. Every TEM lab employs its own variation on a theme, from differences in all these things. Some of these things have been empirically derived, and others have been inherited. And so we have inherited versus empirically derived lab traditions. We've always done it this way. Also superstitions. Sometimes we don't know why we do things, but we still do them. And then the factors out of our control, the buffer, the fixative, in many cases, what's coming in the door, you can't tell them what to do. And then if you move to a new lab, if you have lots of a particular resin or reagent, you'll tend to use it before you buy new stuff. And then flexibility. Many times, core lab in particular, someone will walk in and say, "Here's some samples, and here's a paper I read from 20 years ago. Use this protocol." Randy Massey here at UW, where I am, calls it the "bake me a cake" conundrum. Someone comes in, hands them some samples, says, "Bake me a cake," and the question is, well, my recipe or yours? And then also your imaging modalities, what you have. If you have a bunch of volume EM, you'll be doing that. And if you don't, then you won't. You might be doing serial sectioning or something. And then the tools that are available, and we'll discuss those in a little bit here. Um, I got to whoops. I'm turning my chat. Ruching, would you let me know if there's anything in the chat? I don't have it on with my,
Okay, I will. Yeah.
thank you. Okay, so what trends do we see? We're seeing better cameras that can enhance contrast, sorry for the spelling there, without the need for post staining. Digital processing can improve images. There's some controversy on that of whether you should or shouldn't be doing it. If you do post processing, then it needs to be well documented. Automated specimen processing can free up time and ensure outcomes. And technicians are cautious about handling toxic chemicals manually on a daily basis, especially since alternatives are beginning to exist. Dehydration steps can be condensed. We'll discuss that a little later. And then UA restrictions affect some labs more than others. Great topic. We could probably do a whole session just on that. Um, if you're seeing other trends that I didn't cover, please put them in the chat. So protocol design, it depends. We have a sample, we want some images. What's it depend on? The type of biological source. Is it tissue? Is it cells? Is it organoids? The organ that it's from. Organ is, I'm using that as a catch-all, but is it kidney, brain? Is it liver? What is the source material of the cells or tissue or whatever you're analyzing and imaging? And then what are you looking at? What organelle or region of interest do you want to look at? Some things you'll want to induce some sort of extraction, and some things you will not. And so you may change things like your dehydration protocol. Lipids and membranes may require a different protocol than renal glomeruli, for example. And standardizing, as Ruching mentioned when she was talking, standardizing on sample size can help consistency. So it's wise to do it when possible. And when you're grossing the tissue, everyone, I think, agrees that it needs to be at least 1 millimeter in one dimension. And if it can be 1 millimeter in all three dimensions, that's a good place to start if you can. Just a quick overview of the steps: fixation, rinsing, staining, rinsing. You can read. And what does the workflow look like? And so if you're doing tissue, this example is a biopsy, which an 18 gauge biopsy is right about 1 millimeter. If you've got 8 or 10 long, gross that into 8 or 10 sections and put it into your container. And then you do your fixation, rinse, UA in block if you want to. As was mentioned earlier, this is a particularly voluminous way to do it using your UA post staining with droplet staining, I'll call it, that Alice mentioned is probably the way to do it if you have issues with the UA procuring it and getting rid of it. Dehydration, we'll talk about that a little bit later. Ethanol, acetone, acetonitrile, infiltration, and trimming and sectioning and putting it on the grid, and the grid goes into the TEM. If you're doing the volume EM processing for roto, you'll have multiple heavy steps here. We're not going to go into detail in that today. That, again, can be an entire session. And I'm not going to go through all this, but all the workflows are essentially the same except for the beginning. If you have cells or small amounts of thing, you want to spin them down. Some people embed them in Augur. Sometimes you have to, sometimes you don't. And then also if you're doing things on cover slips or other supports, then you can also leave them in the plate they were in. If you're going to use something like polystyrene, then you have to dehydrate with ethanol or it will dissolve your plate, or you would move your substrate over into a polypropylene plate, and then you could use acetone or some other solvent of that sort. Fixative. I find this particularly interesting. We always call it Karnofsky's, which is some amount of glutaraldehyde and some amount of formaldehyde. This is the entire, when I looked it up, I thought it would be much longer paper. These two paragraphs are the entire reference when you're going to reference Karnofsky's fixative. And interestingly, exceptions to every rule, it works well except for liquid droplets, which are extracted. If you want them extracted, then use Karnofsky's. It's not, he's recommending right here not to. And then this came up in a different forum with the volume EM group. The osmolality is high. Despite the high osmolality, shrinkage is unusual, is what's stated here. So that's an interesting topic I could dig into. Also, he talks about using catalate or phosphate buffer, which is something that different labs do differently. Karnofsky's fixative, again, it's officially 2.5% glutaraldehyde, 2% formaldehyde. Many modifications. They still call it Karnofsky's. One example here, this is Michael Kosterny. He's very astute in the art here. He's doing 1.5 and 2.5, and that one's in phosphate buffer, just an example. And do you have a preferred buffer? The catalate phosphate buffer discussion is one that I find very interesting. Many times a lab will have a preference. And then there are people who are on either end of the spectrum here or who are very set in their ways. Centrifugation, Ruching had brought this up. An interesting way to do fast infiltration was published here by Kent McDonald back in 2014. Rapid infiltration was achieved by centrifugation through increasing concentrations of resin followed by polymerization at 100 degrees. And the 100-degree polymerization topic comes up fairly often. So that's, I know a lot of people do it at 60 or 70, and there are reasons to do it at 100 and not. And rinsing, 3x15 is what's recommended in Bazola. Use the same buffer, consider the size. Rinsing is pretty straightforward in many cases. To Ruching's efficiency in reagent use, especially if you're on a robot, instead of doing, say, 3x15, you can do 5 rinses that are shorter and use less volume, but each time you're diluting it more by basically doing a serial dilution with more rinses instead of larger volumes. That's one strategy to be efficient and still get excellent results. Types of agitation. Agitation is highly recommended. Some people do none. The standard rotator, if you're doing scintillation vials, is quite common. The nutating mixer is the plate that tilts and goes back and forth. You can put scintillation vials, or a lot of people use falcon tubes. If you're using the Dunker type over here, if you're using the MPrep system, the MPrep capsule, you're doing aspirate and dispense mixing. If you're using one of the carousel type processors, we call that dunking, where you've got all your samples in this basket set up and that gets dunked in the reagents. And then on the PrepMaster, you have the shaker agitator. It's particularly important with infiltration. Heavy metal staining, rinsing, pretty straightforward. One thing to consider to be more efficient is to reduce osmium with potassium ferrocyanate. That's done commonly in volume EM, and I think labs have noticed that if they do it in their normal processing, in their standard resin embedded processing, that you can increase contrast, and perhaps this also leads to less post staining in many cases. Dehydration, I would love input on this. People use ethanol historically and then transition solvents. Some labs I've been associated with have transitioned over to acetone to not have to do a transition solvent and do the dehydration in acetone and also mix your resin in that. Acetonitrile is becoming more popular, and people start at 30, 50, 70. The resin itself can make a difference. If you get hard plus 812 resin, you can start at 70% is what they recommend in the user's guide. And how do you do it? We'd love to hear why. Infiltration, embedding, and curing. Agitation is important for timely and thorough ambient pressure infiltration. Alternating vacuum and ambient can help with penetration, and that can be done in a standard vacuum oven, or there's a device from EMS that does it automatically, and particularly helpful with difficult to embed samples. Microwave assisted processing, very fast, improves in larger tissues. It can improve reagent penetration. However, it's highly manual and labor intensive, as people who use it know, and sometimes it can be inconsistent and have some thermal artifacts that occur. Based highly on the skill of the user. It takes a skilled user to do microwave still. So what are some overall design strategies we can look at? Look to big pharma for tools that trickle down to hospitals and researchers, which is what we've done, with the ASP 1000. That was the approach there. And then using these things with, multi-channel pipetters. One thing Ruching and I talked about, we both use pipetters because we have a lot of people will use glass burettes or different things that you're not measuring to be the most accurate and reproducible. Even with putting rinses in and out, it's probably a good idea to measure how much you're putting in and removing. And of course, if you've got a robot and you can do walk-up automation, it makes all of your liquid handling steps very precise and accurate. One thing you can do is have multi-run reservoirs. People have commonly done that with ethanol, make stock ethanol and keep it around for a while. You can pre-dispense and seal reagents if you're using, a PrepMaster or an ASP 1000. That's one example of that. And always consider Occam's razor. If you're doing two things and there's a simpler way to do it and everything else is equal, the simpler way is probably the better way. And remember that time is money. Staff time is precious. So what are some summaries? Use mechanical agitation to improve penetration and speed. As Ruching mentioned, consider alternative dehydration protocols. Ketol 651, low viscosity epoxy resin for embedding. Dehydration agent itself, it's miscible with water and alcohol. So that is another way to perhaps condense your dehydration and resin steps. And try to contain your per sample cost. This is being efficient with your financial resources. If you can use fewer scintillation vials and fewer, expensive burettes, minimize reagent use and minimize waste, as was pointed out. UA waste, it's $1,000 to get rid of 100 mils in New York City. and use smaller volumes and more rinses to maximize dilution. And you can optimize for quality, throughput, cost, speed, reproducibility, and sustainability all at the same time. Additional optimization, if you can, use one organic solvent. One thing I discovered not long ago, this was new to me, was you can deactivate your osmium with your used ethanol, which we do on the robot. Many people reuse their UA. It would be interesting to find out who does here. And if you need advice, there's a Slack channel. Most of the people here are on it. If not, we will, send a message to bioemtalks@gmail.com and we'll send you a link. But Vale shared recently, I'm working on Drosophila. Have you tried? And you can get some real good feedback there. Really quickly here, core labs and shared resources. Ruching had mentioned that the folks at University of South Carolina have combined their core labs, and maybe not necessarily combined, but they've made them all accessible on one platform, which it does reduce administrative burden, but it also makes it easier for new staff or people who aren't on the in with people on campus to find the different resources that are available, and makes it more democratic, if you will, for all the people on campus, and they can guide themselves through continuous improvement. What are some things we're going to cover in the future? Working with the Volume EM sample prep group led by Melania with the Empire sample prep widget people, we're envisioning, and this is not going to be an easy tool, and there's going to be a lot of pain making this, if it can be made, but a tool to guide protocol development. And right now, feasibility, we're going back to one of the earlier slides of specifying the type of sample, the organ or source material it came from, and then the imaging target. So we'd be looking at, tissue biopsies from kidney and glomeruli on kidney, for example. And then to be able just to plug those things in and get a suggested protocol that would, of course, have to be curated. How to select resin, that's a whole topic right there as well. Different options for automation, we can go deep into that at some point. And online EM learning resources in parallel with the CEMT certification and other things, other ways for people to learn the topics that are popular. And if you have other ideas that you would like for us to cover, please don't hesitate to send an email to bioemtalks@gmail.com. Do we have any questions?